Welcome to Evolution in Controls. I'm your host, Tim Wilson. Thank you for joining us. In Season 2 of Evolution in Controls, we introduced Morel Industrial's engineered linear modules, a pre-engineered linear movement system capable of heavy loads and high speeds. We explored how these modules play a pivotal role in a moving robot transfer unit. RTUs are more than just an extension of a robot's working range. They're a fundamental component in modern automation, vital for handling substantial workloads in large-scale production. But the landscape of automation is ever diverse and ever evolving, and there's another notable system that we haven't discussed. It is the CTU, or Collaborative Robot Transfer Unit. While a cobot transfer unit may share many functional similarities with RTUs, they bring a unique element to the table. They thrive in environments that require human-robot collaboration, melding the precision of automation with the adaptability and ingenuity of human skills. Understanding the nuanced differences and similarities between RTUs and CTUs is crucial. Choosing the right one hinges on factors such as production needs and the intricacies of the tasks at hand. Guide us through these important details of these systems and the way Morel Industrial tailors solutions. We're joined today by Tom Rinke, Advanced Engineering Manager, and Jim Dougherty, Mechanical Product Manager. Guys, thank you for joining me today.
Thank you for having us, Tim. Thanks, Tim.
Jim, you're a first-time guest here, so why don't we start? Introduce yourself, tell us a little about yourself, and how long you've been with Morel.
Okay, I've been with Morel for 9 years now. Mechanical Engineering Product Manager. I've previously held mechanical engineering positions, managing groups and developing everything from automation to houses. So,
Okay. So a pretty broad background.
yes,
Experience with robots?
yes. Yeah, previous job was working with robots.
All right, so you're going to be able to help us today.
Absolutely.
Tom, you've been back here before. You're a retread.
Yeah, I've been here. Not a first timer.
All right, but refresh us. Tell us a
So
little
my
about
name's
yourself.
Tom Rinke. I'm an advanced engineering manager, and I lead the Motioneer team. I've been with Morel just a little bit over 3 years now.
Okay. Well, as I said in my introduction, we're here to talk about cobot transfer units, but I thought as a start, let's talk about RTUs. We talked about that in a previous episode, but remind us, what is that RTU?
So the RTU, and as we previously discussed in our engineered linear module segment, is that it's a subset of that. Really, it's an application-based module that's meant for industrial robots. So large scale, long travels, high loads, possibly higher speeds. So it's really a very specific application of an engineered linear module, specifically for industrial robotics.
The robot rides on top or sits on top of the pallet or the plate, and it moves back and forth.
Right.
How is that RTU controlled? Jim, is it independent? Is there a separate controller? How does that work?
So it works with the robot controller. So it's actually another axis that helps the robot move linearly down production line or weld line. It's part of the robot kinematic programming. So it's another servo and drive within the robot controller that's programmed using the whatever manufacturer's code, robot code is.
So the RTU is made by somebody other than the industrial robot manufacturer, but yet it's controlled by the industrial robot's controller.
Yes.
Okay. And as it moves, that controller is looking at the point space, including the seventh axis? Or
Yes, the seventh axis. It's a part of moving the robot to its programmed location. So it's a part of the robot kinematic axis. So typically a robot is a 6-axis robot sitting on the adapter that's on top of the RTU. And there's another servo motor that's in the 7th axis, typically running on, rack and pinion type gearing.
We've got a picture of it behind you. It's a ball screw driven one, but there's the servo motor, and it's industrial robot. So the point space is calculated by the robot controller and just moves that RTU.
Yes.
All right. Now we're talking about CTUs, or a collaborative robot. What's the difference? Let's start with that. What's the difference between a industrial robot and a collaborative robot?
Okay, so functionally, they're really the same thing. I mean, construction-wise, all the components, those are very much the same.
Functionally.
Functionally. The collaborative robot, obviously, because the robots are smaller, typically reaches, sub 1 meter up to maybe 2 meters. Payloads that don't
in reach for their robot?
And reach, yes. And collaborative robot payloads don't typically exceed like maybe 20 kilograms. So, those...
It's not very heavy.
Those loads and those envelopes kind of drive a CTU solution to be a little bit more lightweight, possibly like an extrusion construction rather than a weldment or a fabrication. And, and then you're talking about, maybe the loads are a little bit lighter, so you really don't need maybe a rack and pinion. Maybe you could use a belt module or a belt drive system.
Well, are the robots, Jim, you work for a robot manufacturer, are the robots the same? What are the difference between the robots themselves?
Okay, for a collaborative robot has to monitor its torque values and its positions to work side by side with an employee or
a human.
A human, right? Whereas an industrial robot doesn't really have that type of monitoring, doesn't have that control. So the industrial robot's going to go to a point regardless of what's in its way.
So in plants that I've been in, an industrial robot has a cage around it. Nobody's allowed in the cage. Robot's not operating. A collaborative robot is not the same?
It's not the same. You can work next to it.
What makes one safe and the other not?
It's all based on the robot programming. So the robot programming is monitoring its position, it's monitoring force feedback, and if it sees something outside of what it's programmed to do, it shuts down.
So an industrial robot, if you tell it to go to a point in space, it's going to use its full torque and full speed or programmed speed to get to that point in speed, regardless of what's in its way.
Correct.
You're saying that the collaborative robot is monitoring force feedback. So if it encounters an obstacle or resistance, at some point that resistance is going to trigger it to stop?
Yes. Yep.
That's what makes it safe or safer?
Safer to work next to.
Okay. All right. So Tom, what you were saying, because of the differences in the two robots, you're saying that you don't have to design the transfer unit to the same specifications or the same levels?
Yeah. The guidance system doesn't need to be as big or as heavy because the loads are lower, right? The speeds may or may not be the same, but the payload is less, right? So you don't have to have
I'm not moving as much weight.
Right. So you can get away with a belt module. You can get away with accuracy levels are a little bit less sometimes.
A collaborative robot generally would weigh much less than an industrial robot,
Yes,
right?
that's correct.
So just from the robot itself, I'm moving less mass. And then the loads that it's carrying is factor of 10?
In some cases.
Okay. 10 less.
Yeah, correct. Yep.
So what kind of drive mechanism? So on the one behind Jim that we looked at, that's a ball screw.
Right.
But I think you said that generally an RTU could be, if it's long distances, it's what, a gear rack?
Yeah. Typically for an RTU, because you do have extended length and maybe a little bit higher loads and maybe a little bit higher precision, the drive system is kind of driven towards a rack and pinion solution. You can make those in excess of 5+ meters. You can continue to go. If you're inside of that, which most collaborative applications are, you can stay probably in a belt module, something that's a little bit less, right? I mean, you can get belt modules that go 3, 4, 5 meters.
15, 20 feet.
Right. And even that, even if you had a CTU application that was longer, you could use a rack and pinion. It's not really a requirement.
But a belt has a less of a load capacity than a gear rack would.
Correct.
Has generally less precision than a gear rack would because of...
It has a little more compliance in it.
Yeah.
Right.
I was going to say because of strain, it's going to move or stretch.
Correct.
All right. How has the adoption in industry been for CTUs? Are they really coming on strong? Have they been around for the last 15 years?
I think as a general robotics solution, they've been around for a while. Collaborative robots have really kind of been in the mix for, you're really talking about almost 10 years now. But I think the industry adoption is just going to continue to grow. There's a really deep base of knowledge about industrial robotics and RTUs. And with the collaborative robots being a little bit different from a control system architecture standpoint, I think as more and more of those systems get out in the field and more people understand the applications and what works and what doesn't work, I think you're going to see more and more of that. You're going to see more adoption, more use of the 7th, 8th axis systems, and just people are going to find the best use cases for these robots.
You know, you talked about the 7th or 8th axis. One of the questions that still is in my mind, Jim, is we talked about how the 7th axis for an RTU gets controlled. How does the CTU get controlled? Same way?
No, no, it's basically Ethernet communication between a programming device like a PLC, or that's how it communicates. So it's not a part of the robot kinematic.
The kinematics package?
Correct.
So it's a collaboration between two separate controllers.
Sure.
All right. So as we look into the future, do you see any changes coming in the technology, in the adoption? What do you think the next 5 years are going to look like?
So, in my opinion, I think you're going to see a lot more collaborative robots come into the automation world, working side by side with a human. A little more adaptability than like hard automation.
Replacing industrial robots, or doing things that maybe you wouldn't have done with an industrial robot?
Things that you wouldn't have done with an industrial robot.
And with the CTU to move them around, it expands the range of what you could have a CTU do. Is that?
Absolutely, absolutely. You can put this robot right next to a human and actually enhance the whole operation.
Right. Fascinating. Guys, we've kind of run out of time. I've got lots of other questions I'd like to ask, but maybe we'll look at this in greater detail. Marel is coming out with a line of CTUs, right?
Correct.
Maybe we can come back and talk about that whole line of CTUs. It sounds like it's going to be a prepackaged.
Very similar to the engineered linear modules. It'll be pre-engineered to some extent, right? Based on the industry kind of standards for the collaborative robot sizes.
More available from inventory or from stock rather than a custom design?
Yeah, I think that, again, because of the scale and construction, we may be able to incorporate some of our standard product offering.
All right. We need to talk about that in the future. I guess we're going to have you come back, Tom.
All right, I'll do it.
Jim, love to have you back too as well. Thank you for joining us today.
Yep.
Guys, thank you very much.
All right, thanks.
Thank you, Tim.
To learn more about Marel Industrial and their systems and solutions, visit marel-group.com. Don't forget to subscribe to Evolution in Controls on whatever platform you use for podcasts or on YouTube for a video version so you can be updated when we release new episodes. Thank you again for joining us today. I'm Tim Wilson, and remember, keep moving.